is the point Q on the circle with center C? So we have some point Q on xy plane and we need to just answer whether point Q is lying on the circle with center C or not. The answer to be given in the form of either yes or no. The first statement says that R is a point on the circle and the distance between Q and R, that means QR, is equal to the distance between QC. So let's quickly draw the two circles and just try to understand whether we get point Q on the circle or not. We always like to draw the two scenarios in order to prove that the statement is not sufficient. So let me just quickly try to draw two circles here. Now, one possible case is QR is equal to QC, where C is the center. So we can take a point such as this, and we can also take another point such as this. So what I've done is, this is point C, and we already know that R is a point on the circle, so I have chosen point R here. So, and the distance between Q and between Q and R is equal to the distance between Q and C. So distance between Q and R is equal to the distance between Q and C. That is a possibility if we have drawn a triangle such as this, which is an equilateral triangle, because all the three sides are equal. So the answer of the question could be yes according to this particular case. Now let's try to draw another possibility. So once again we have to check that QR should be equal to QC. So while I've chosen C and R exactly at the same point, I am choosing a point Q in a space here such that this distance is same as this distance. So I was trying to draw an isosceles triangle with CR fixed and these two lines are equal, but the Q point is not on the circle, it is inside the circle. And the answer to the question here is no. The first statement does not confirm whether Q is on the circle or inside the circle, because we have got the two possibilities which are contradicting. Therefore we say that the first statement alone is not sufficient to answer the question. Now let's check the second statement. The second statement says that S is a point on the circle and the distance from QS is equal to the distance between S, C. So even in this case, let's quickly draw two circles here and try to prove that this statement as well is not sufficient. So let me take once again the 2 points. One point is C at the center and another point S is on the circle. So in both the cases S is on the circle, in both the cases C is a point which is center of the circle. Now the question says that QS is equal to SC. So we have to choose a point Q somewhere so that QS is equal to SC. That means the distance of Q and S should be equal to the radius. Now one possibility that we can choose is, once again I am drawing the similar kind of figure which we earlier drew in the first statement, an equilateral triangle such as this, where point Q has equal distance from S as it is from point C and the distance between point C and S. So considering this particular case, we can say the answer to the question is yes. Now, but the second possibility is Q could be anywhere in the space at a distance which is equal to the radius of the circle, which means the second possibility of Q that we can draw is somewhat like this, where this line has same length as this line and Q is not on the circle. So again the second statement alone is not sufficient to answer the question. We have proven that the first and second statements are not sufficient, so now the third stage is to combine the two statements. We will combine the two statements and we can see that one case is common to both the statements that we have drawn, which is considering point Q on the circumference and drawing an equilateral triangle with point R, C, Q. Right? So let me quickly just draw one figure which says the answer to the question as yes, and then we will think about the second possibility. So here we have drawn a figure in which this point is C, this point is R, this point is Q, and these two sides, all these three sides are equal. So the first and second statement both are satisfied, and where we are taking point R, we are taking point S as well, exactly right there. Now let's try to draw another possibility. Another possibility in which we want to take Q at some point other away from the circumference. So let's take point C and R still at the same places. So we have this point C here, we have this point R here, and now we can take a Q point somewhere at this place. Now let us see what happens. QR is equal to QC, and QS should be equal to SC. So now I am choosing another point S right here. So QS is equal to SC. So we have been able to choose a point Q which is exactly the midpoint of RC, and we have chosen another point S here, and the Q point is not on the circumference, so we still have the answer to the question as either yes or no. So the statements together as well are not sufficient to answer, and the final answer to the question becomes option E. Thank you so much.